In this unit, it's called kinematics. This is studying the motion of objects. We have two different types of units that are associated with kinematics. The first of these is scalar quantities. These are things that we see on a daily basis. We may be talking about speed, such as 30 or 100 kilometers an hour. We may be talking about distance, time. These are all scalar quantities because they have a magnitude, which is a number or a size, but no direction. If you look at the speedometer of your car and it says 100 kilometers an hour, that is a scalar. If you attach a direction to that, so say 100 kilometers an hour east, that then becomes a vector quantity, and we'll get into those in a little bit. But in terms of just one quick thing with speed, the variable for speed is v, and VAV stands for the average speed, equals delta d over delta t. Delta is a common thing we're going to see in physics. Literally means the word change. So the average speed equals the change in distance divided by the change in time. So Molson Indy in Toronto, one lap is 2.90 kilometers at an average speed of 150 kilometers an hour. I want to determine two things. One, the average speed in meters per second, and second, the time it takes to complete the lap. Well, for A, we already know that the speed is 150 kilometers per hour. Which literally means you would go 150 kilometers in 1 hour. If you were able to keep that exact speed for 1 hour, you would go exactly 150 kilometers. Now, I want the speed in meters per second. So we not only have to determine how many meters are in 1 kilometer, but how many seconds are in 1 hour. Well, we should remember that there are 1,000 meters in a kilometer. But it may not be so obvious how many seconds are in 1 hour. Well, this is actually two parts. We know that there are 60 minutes in 1 hour. And so that would give us 1 times 60 would give us 60 minutes. And then we also know that there's 60 seconds in 1 minute. So multiplying that all together would give us that there are 3,600 seconds in 1 hour. Doing that calculation, and in physics we will always go to significant figures. We were given 150 kilometers per hour in the question. Yes, we were also given 2.90 kilometers, but we didn't use it for this. The conversions of 1,000 meters and 3,600 seconds do not count in sig-fig determination. So the only piece of information we look at for sig figs is 150 kilometers. It has 2 sig figs, so the final answer will also have 2 sig figs, which will give us 42 meters per second. Question B, the time in seconds it takes to complete the lap. This we will need to use an equation. And what we'll see as we go through this course is sometimes we will have multiple equations we can use. Sometimes it won't be clear which equation to use from the get-go. So a process called defining the variables becomes almost essential. This consists literally of listing out all of the information we know, attaching it to the variable that it goes to, and then matching it to an equation. So what we know is that the average speed, we just found that in A, is 42 meters per second. We also know the distance that this race car traveled at 2.90 kilometers. But with any calculation in science, we do need to take that to standard units, which would be meters, which would give us 2,900 meters. And I am going to put a line over that 0 to keep 3 sig figs. And the question's asking us to find the time in seconds, that is delta t. We only have one equation that we can use. So in this case, defining the variables was not the best use of our time, but it is a good habit to get into as we get into more complex questions and questions where the equation isn't clear. So at this point, we can substitute in 42, 2,900, simple equation here to cross multiply. So we get 42 delta t equals 2,900. Divide both sides by 42. And looking at the sig figs, our average speed, 42 meters per second, had 2 sig figs. Our displacement, our distance, had 3 sig figs. We always go to the smallest number of sig figs when we're doing a final answer. So 2 is the smallest. So 2 sig figs would give us a time of 69 seconds.